Hello and welcome. Thanks for joining us for our presentation, Jana's Data Warehousing Story, Then versus Now. Before we begin, I'd like to cover a few housekeeping items. Each attendee is in listen-only mode for the duration of our presentation. We will be engaging with the audience through a question and answer session at the end of today's webinar, and we encourage you all to submit any questions you might have at any time during today's presentation through the chat feature you see in the lower left corner of the ReadyTalk platform. We'll be taking as many questions as possible, and if we don't address your question directly, we'll be sure to follow up with you individually. At the end of our presentation, each presenter's contact details will be available. Today's presentation is being recorded and will be available following the presentation. Snowflake will be sending you the recording by week's end. Today, we'd like to introduce you to Jana. We'll take you through how Jana is managing data as an analytics and metrics-centric organization, and how Jana's supporting data architecture has progressed by making use of the cloud. Now, I'd like to welcome today's presenters. Craig Lancaster, CTO with Jana. Mike Ruiz, Solutions Architect with Amazon Web Services. And John Bach, VP Marketing and Products from Snowflake Computing. Gentlemen, welcome, and let's get started. I'll pass the presentation over to Craig from Jana. Craig, thanks, and please take it away.
Great. So at Jana, our mission is to make the internet free for the next billion. What this means is that there are millions and millions of people throughout the world who can now afford a highly functional smartphone, usually an Android phone. And those costs have dropped very low, under $50, unsubsidized in many cases. But the cost of data has not dropped in a similar manner. So there's a situation where an Android phone is the primary means of accessing the internet in countries like India or Argentina or Brazil or Mexico for many, many people, but they can't consistently afford to buy the data access that they need to actually be on the internet. Jana has built an application that we call MSense that lets people receive free data in exchange for interacting with brands, currently primarily by trying and using Android applications. But over the next year or two, we will be introducing further ways for them to unlock this value. We deliver the data through integrations with more than 300 partners in nearly 100 countries. And our key countries are highlighted on this current slide. As you can see, they are spread throughout Latin America, Asia, and parts of Africa. And more than 1 million people are using MSense every day in order to help them have the access to the internet and therefore the rest of the world. Now, Jana is a small company that is based in Boston, and we're operating in a large number of cultures and countries around the world. And we realize that while we do the best we can't understand deeply the best way to encourage people to engage successfully with brands in each of those countries. So we're dedicated to doing that through the data that we can collect and analyze and understand. We have 4 core company values, one of which is measure it, and we really do run our data, our business on the data that we collect and analyze. We're constantly introducing new features into the application, and all of those features are introduced through split tests, which we then analyze and determine their impact on several key metrics, such as user retention, the lifetime value of the user, and the delivery of the KPIs that are important to our business clients. We're also continually optimizing the campaigns that we run on behalf of our clients. And we have an interesting problem in that we give something that's pretty close to money to people over the internet. And so fraud management is a real issue. And we must continuously monitor activity in the system in order to detect and contain any attempts to take the internet access that we provide without, in a manner that would be considered fraudulent or not of value. So there are several key uses of the analytics system that we've built out over the last couple of years that derive from these needs. We have regularly updating business dashboards that sit on big TVs internally and employees are accessing all the time from their computers and cell phones, the typical daily reports that you would see throughout many organizations. Our product managers are constantly analyzing how well each of the variants of the features are doing in production to determine which variants should be turned on for everybody and which features should perhaps be turned off and removed from the products. Both sales and marketing are continually accessing data to both drive new business for Jana and to deliver collateral and insights that will enable our partners to understand the value that we can add. And we also have a series of systems that do low latency monitoring of our business constraints to help ensure that we are not losing money in any particular country, and that's to catch both bugs and fraud and just unexpected developments in different countries. There's some key parts of the system that have not changed over time, and I'd like to introduce them first just as context because they did help drive some of the key decisions that we've had to make. All of our code has been and will remain deployed within Amazon Web Services. We're primarily in a few availability zones within US East, but we also have a smaller number of servers that are running in the Singapore data center and the Sao Paulo data center. The bulk of our data is being generated through our web applications and the server-side API for our Android application. All of that code is written in Python using the Flask web framework behind Nginx, and all of that data is being stored within Cassandra or Redis. We decided early on to standardize on Apache Kafka as our data bus. So all of the data that winds up being inside our analytics and system and eventually winds up in our data warehouse gets there by being published into Kafka. We deployed Kafka 0.7.2 over 2 years ago, and it has been working quite reliably for us to the extent that we have not upgraded, simply because other parts of our system needed the attention much more desperately. The upgrade to 0.9, which came out recently, will probably happen in the first quarter of next year. But Kafka has been fabulously stable in performance, and the only drawback we've seen is that sometimes Python consumers can't keep up with the rate of data that we're sending through Kafka. However, rewriting those consumers in Java has solved that problem neatly. And then all of the data that we're sending through Kafka is encoded using the Avro binary encoding. We currently have 37 distinct types of data. Some examples would be counting user events. That could include opening the application, trying one of our clients' Android applications, sending a message to a friend, that sort of thing. We also have accounting records where we keep track of the value that we're transferring into user accounts, user profiles, campaign configurations, and so forth. And having typed data schemas with reliable forward evolution has prevented a large number of bugs that we've seen in some other setups that I've used in the past. So when we set up our initial architecture for this analytics system, we were still an early stage startup. We did not have a large amount of usage yet. In fact, we set the analytics system up before we publicly launched our Android application. So our key goals were to get something together that quickly that would work for the time being and whose structure could remain for the long run. But we knew that we might have difficulties scaling certain parts of it at the time, and that was okay. So there were 3 main parts of the initial system that we set up. The first part, which is in the unshaded box on the slide, was our scheduling and coordination layer. For that, we simply used cron invoking bash shell scripts to keep things simple. We also wanted to encourage all of the real complexity to not be in the, we wanted to encourage the original complexity to be, contained in the rest of the system and not in the scheduling scripts, and bash is quite effective at deterring engineers from trying something complicated. The darker shaded boxes on this diagram represents our ETL pipeline that was responsible for taking the raw data that we were recording and transforming it into a form that could be used for our other purposes. As I mentioned, Kafka is the initial source of all the data that's coming into the system. We then take all of that data and store it unaltered inside HDFS. And we never, after that, either mutate or delete that data. The aim there was to have an expandable data storage layer where we could keep all of our raw data, which would allow us to run interesting new analyses on the unaltered data, or to rerun analyses after we found and repaired bugs further down the pipeline. So we were looking for the simplest way that we could simply store the data unaltered for a long period of time. After that, we ran a series of MapReduce jobs that were written in Java to transform that data either into more complicated aggregations, which were stored back in HDFS, or to transform it into flat files, which we would then load into our relational database. And the relational database we were using at the time was MySQL, which we chose simply because we already had an instance running and we knew how to operate and maintain it. It's also worth mentioning that the HDFS and MapReduce jobs were running on a small Hadoop cluster that we were administering and maintaining ourselves, running on EC2 instances. The final part of the initial system was the tools that were used by Jana employees to understand what was going on, what the results of all that data analysis was. And these are the lighter gray boxes on that diagram, and there were three primary systems. The first of those were some internal dashboards. As I mentioned earlier, they're up on big TVs in our office and are regularly monitored by everyone from executives to salespeople to engineers to see how many people are using our application, how much money we've made that day, and a number of other internal metrics that we monitor. We have a very technical team here at Jana, so it is actually quite common that people are just using SQL clients to access the raw data and build their own analyses. And so we have both engineers and data analysts on the sales team and product managers regularly performing queries using various SQL clients. And then finally, our data science team primarily uses IPython notebooks to do their more sophisticated analyses. So the results with the initial system, it took us roughly a quarter with about 1.5 people working on it to build the first version of the system. We continued iterating on it for quite some time after that. But initially, this setup worked very well for us. The dashboards and the database data were being updated 3 or 4 times a day. It's worth mentioning that we considered and intentionally did not aim for continuous updates for a variety of internal reasons. We do have some monitoring that is continuous, but it reads directly off the Kafka data and doesn't work off the rest of the system. And as I mentioned, we had product managers, software engineers, and data scientists all regularly querying to evaluate how features were doing and how our business was operating and understand what was going on. However, when we launched the MSent application, we were fortunate to have fairly rapid success, and we scaled pretty quickly from our initial installs to more than 1 million people using the app every day. And the data volumes grew in conjunction with that to the point where we started hitting problems. The core problems we hit were simply that we wound up having more data than a single MySQL instance is designed to or efficient handling. When we stopped using MySQL as our primary analytics data store, there were 12 terabytes of data on a single MySQL instance. And there's a number of problems that resulted from having this much data in one system. First of all, it's too big to use Amazon's RDS option. The largest of those, I believe, is just under 4 terabytes, or it was at the time anyways. So we had to do all of our administration ourselves, and as the amount of data being stored on the one instance got larger, the administration became harder. Things like expanding the amount of storage available for the database took an increasingly large amount of time. It also became increasingly difficult for table design to be done so that the queries we needed to execute would be efficient. and it became impossible for us to execute queries that required scanning the entire table. It simply would take long enough and hold enough locks that other queries would start failing, and there was just a variety of trouble on that. It was a lesser issue, but we also had to spend an increasing amount of time maintaining our own Hadoop clusters. It was largely adding capacity and taking backups for HDFS, but it was becoming an almost weekly occurrence as our data rates grew. So we realized that we needed to redesign before we got to a point where we could no longer run the business in the way we had become accustomed to running it, and that is driven by data and smart analysis of that data. So we did some evaluation and redesigned parts of the system. And a key part of our new design is Snowflake. And so now I'm going to hand it over to John. I'm going to hand it over to Mike, who's going to talk about how AWS played into some of these changes.
Well, thanks a lot, Craig. So my name is Mike Ruiz. I'm a solutions architect working for Amazon Web Services for the partner team. And today we're going to take a look at Amazon S3, which is a technology for the Snowflake solution, so as other solutions that Craig talked about, so HDFS, for instance. We'll talk about some updates that we've made to the service this year. So as a quick overview, Amazon S3 is a highly durable object store for all types of data, and is especially relevant for big data because it's an internet scale service. So you can grow without limits. You can store as little data as you need, and then scale that out as your business opportunity grows. For durability, with 11 nines of durability out of the box, and 9 of availability, you can adjust that durability and availability characteristic by making additional copies automatically with lifecycle policies, or by moving the data to infrequent access or reduced redundancy storage. It's a low-price service, a low-cost service that involves no commitment and no upfront costs, so you're going to pay for exactly what you use. So as your data grows on the platform, the cost will increase, and as you're able to lifecycle that out or take advantage of other opportunities, your cost will go down if you move the footprint down. So there's no commitment. You can move it up and down. Your cost will go up and down as your data changes on the platform. And then finally, Amazon S3 is no different from any other AWS service. The security is the most important feature of the service for AWS. And so you're able to protect that data with a variety of policies and roles. You're able to protect that data with encryption should you wish, either automatically encrypted or client-side encrypted. We support both use cases. We pay a lot of attention to compliance and regulatory regimes, and customers and partners are able to build HIPAA, FedRAMP, PCI compliant platforms using S3 as part of the workflow, or to store the result sets from analytics. So S3 is absolutely integral to the AWS and partner ecosystem solutions built on AWS. I think Craig mentioned some of the enabling technologies. So S3 is the foundational technology to power RDS backups, for instance. It's also used to hydrate and back up HDFS or Hadoop clusters on the platform, frequently used in that use case. It's fully integrated with AWS's other object storage options, for instance, our archival store called Glacier. You can create policies to easily and automatically move data from S3 to an archival tier, or back if the case arises that that's required. Amazon S3 is fully integrated with our content delivery networks, so you can take advantage of any one of the 50 edge locations to deliver content stored in S3, for instance, reporting content or the result of a production analytics workflow to users wherever they exist. And finally, Amazon S3 directly powers workflows like Snowflake by providing a high-speed, durable storage tier. So you have a choice of object storage classes on AWS, and Amazon S3 as an entry point to all of them. So you can store data that has frequent access characteristics, for example, data that's in a production workflow or in a production analytic workflow. And then as the access needs change, you can automatically move that data to an infrequent access tier, or finally archive the data off to Amazon Glacier. You can reverse that arrow and move the data back up through the tiers as your needs to access the data change, all by operating the Amazon S3 API. So using lifecycle policies, you can lifecycle data out to Amazon Glacier, but yet still access it using the Amazon S3 API. So as promised, we've got some new features for 2015. For Amazon S3, Amazon S3 was initially launched as the first AWS service in 2006, and since then has received a lot of updates. As the first service, the read after write consistency in the standard region was not the same as the follow-on regions. It now is, and so after you commit a write to any S3 location through any endpoint, you'll be able to read that data immediately. We've also released the S3 bucket limit increase, so lots of customers and partners prefer to use buckets as an organizational principle. And we've released the bucket. We've allowed the customers to take advantage of buckets in their account. We also have 6 other services that I'll get into in a little bit more detail. One of the key ones is S3 event notification. So I mentioned that Amazon is integral to many analytics workflow. So you can now event direct off API use of S3, create SMS topic updates or submit entry into the an SQS or an invoke a Lambda function directly as a result of a number of API operations on S3. So this creates much easier and much simpler and fast to integrate S3 into an existing workflow. Amazon S3 now supports automatic cross-region replication. So S3 is a regional service. It's available on any or all of the 11 AWS regions around the globe, and will be available in the additional 4 regions coming online in 2016. It's always possible to move data between Amazon S regions. We now offer the ability to do that automatically with a click of a few buttons. So why would you do this? Lower latency access to data. In the US, and you'd like to make that available in Brazil, you can do that with a cross-region replication policy. They might have a compliance regime that they're trying to comply with. They might like to store data in different geographic locations for that. Again, cross-region replication enables that workflow. And finally, for security, you can move data cross-region, but you can also move it into a different account or different security regime. So if you have data that you'd like to protect with a much more stringent access policy, you can move it into an entirely different account in a different bucket in a different region. So M3 VPC endpoints are a new feature, a little bit more complicated to explain, but I'll give it a go. So Amazon S3 historically had been accessible through the public internet API within a region. So even if you had EC2 resources or other resources in a VPC or virtual private cloud construct in AWS, you needed to egress to the internet to have access to S3. So it's possible and certainly design patterns to enable that at high speed and with decent redundancy. It was a little bit more complicated and required either the use of public IP addresses on your analytics boxes or the use of a network address translation gateway that the customer had to configure. So as of this year, we've a new click button deploy console, the VPC endpoint. Place that in your VPC, and now you can realize the vision of a truly private analytics workflow that has absolutely no internet connectivity but can still take advantage of high-speed access to S3. Finally, we've added the capacity to put all API use to an existing to a service we call AWS CloudTrail, which tracks all API use on the platform. So if you'd like to understand exactly how users applications are interfacing and interacting with your S3 data, this is now persisted into the product called AWS CloudTrail, which I encourage you to take a look at in every region. And finally, getting data into Amazon S3 has traditionally been through those internet endpoints or through another service called import-export. We've enhanced that service with a new physical product called Snowball. And so if you've got the problem or the privilege of having a lot of data in place in your data center, terabytes of data, that you've been wondering how to get into AWS so that you can perform an analytics workflow on it, perhaps with a product like Snowflake, you either position of either copying that onto a lot of little devices yourself, a lot of little hardware devices, hard drives, shipping it in the AWS, we would upload into S3. Now enhance that service by creating a new device, go into the console, create a job, you'll cite it, and then AWS will send you this physical device. Each one or many of these physical devices, they each can support 50 terabytes of data. You'll plug them into your network, install a client, encrypt the data, put it back on the device, ship the device back to us, and we will replace that data on S3 for the wider ecosystem. So this is a great way to get a lot of data into AWS very quickly. keep it up to date using the standard internet connectivity that you've already provisioned in your data center. So here are some additional resources to look at big data ideas and architectures on the platform. I won't read them to you. This webinar is being recorded, and you can look at these resources. So I'm going to hand it back over to John, and we'll talk about the Snowflake solution on AWS.
Great. Thanks, Mike. So what I wanted to do was go from what Mike had been talking about and some of the key capabilities, especially the ones in S3 that Amazon provides, and talk a little bit about how we've turned those into what we have delivered as a data warehousing solution, that then Craig will talk a little bit about how that fit into their environment. So when you look at the things that we were seeing, it's very similar to the things that Craig was talking about. They had a lot of data. It was coming in. It had a lot of different forms. Avro was one of the key forms there, which is certainly not the type of data that you typically would have put into a data warehouse. As a result of these different types of data and different uses of data, we see people having a bunch of different systems. In Craig's case, they were looking at a MySQL system as being one of their primary data stores, as well as a Hadoop environment. But if we look at larger enterprise type environments, we also see a large number of different data marts that are often also used to store data and make that accessible for analytics. But the complexity of that ends up really impacting the ability to do analytics on that data. So the analysts end up spending a lot of time waiting for data. They often don't have access to all the data that they need. And they often have to compete with other analysts and other workloads for access to process that data. So at Snowflake, we saw these challenges, and we really saw the opportunity to create a new data platform that would help people to solve these challenges. And so what we did at Snowflake was we started out by building a completely new SQL data warehouse. So we did not start with some existing products, open source or otherwise. We actually built the data warehousing engine from scratch ourselves. And we have a team that has decades of experience and over hundreds of patents building data warehouses, and so really knows the ins and outs of how to build a data warehouse successfully. When we built that, we saw just how much data there was today that was generated in the cloud or being processed by the cloud or being pushed through the cloud. And we also saw just the benefits and the rapid evolution of cloud offerings such that we realized that the modern data warehouse definitely needed to be designed for the cloud. And so that's why we actually focused on designing a data warehouse that would run natively in Amazon's Web Services cloud platform. We also wanted to take and make this something that we could deliver as a software service. And what I mean by that is if you look at traditional data warehousing, there's a lot of knobs and tweaking and tuning you have to do. There's a lot of infrastructure you have to manage. We actually wanted to take all of that and take that off of what companies and users had to worry about so that they could really focus on leveraging their data. Because we built this as a SQL data warehouse, a huge benefit of that is it fits in seamlessly with all the different tools and processes that people have today. SQL databases are an established standard for different ways of storing and communicating with data. And so when you take Snowflake, you can plug it in and you can have your ETL tools talk to Snowflake. We support standard ODBC and JDBC connectivity. You can connect your common BI reporting and analytics tools. So whether it's your visualization tool that speaks to Snowflake via JDBC, or maybe a BI and reporting tool that speaks to Snowflake via ODBC, or maybe some other type of analytics application or an R environment, all of those can be easily connected to Snowflake because Snowflake is at its core a SQL data warehouse. What we focused on delivering was the ability to bring together all the different data that people have in one place without having to copy and move it around, because that was one of the big bottlenecks that we did see when we were talking to people who were using data, was needing to move that data through multiple systems and make copies of that data to get it to where it needed to be. We also wanted to make sure that we could make the analytics faster, not only by getting data to the analysts faster, but also by processing the analytics faster that they were operating on, and doing that at any scale that they needed to operate at. And possibly most importantly, we wanted to do that while eliminating a lot of the cost and complexity that had traditionally been associated with data warehousing. Data warehousing is often thought of as kind of a big enterprise type solution, but we really saw the potential to make it something that could be used by a much broader set of use cases by making it much less expensive and much less complex to purchase, deploy, and optimize. So the way that we did that was we started with the realization that we needed to build a new architecture just to take advantage of what was available in the cloud. I talked just a second ago about the desire to bring together all that different data, structured and semi-structured, data from different sources, data for different purposes, all in one place. And when we looked at the cloud, we saw that an ideal place to store data was Amazon's S3 storage service. It's highly scalable. There's a huge amount of throughput you can use to access data in S3. It's highly durable, and it's highly resilient. These are all core properties that are very appealing for storing data. But at the same time, we saw that there's a lot of extremely valuable capabilities in S3 that we could actually manage for the users of the data warehouse. So we could give the users the benefit of all those capabilities that Mike talked about, from security to resiliency to how you manage the data that's stored in S3. And so what we did is we actually built a data warehouse that under the covers uses Amazon's S3 to store and centralize data. It stores that in a very efficient compressed columnar format. S3 scales automatically. There's no need to worry about provisioning storage, upgrading storage, anything like that. And you can get high performance because there is such a huge amount of bandwidth available within the Amazon cloud infrastructure between S3 and other services in Amazon. So once we centralize data there, that helped to solve one of the challenges that people see often when they're trying to analyze data. But the next challenge they see is you can't, in a traditional environment, let a lot of different users and workloads access data at the same time. Because pretty quickly you start running into contention issues. The same users, the same workloads, all competing for the same resources. And as a result, you can only scale to a certain size before you need to start creating other data marts and such. So in our architecture, we explicitly designed a way to make it possible to scale workloads and compute independent of where the data is stored. And that's this concept called virtual warehouses. So in our environment, a virtual warehouse is an independent compute cluster. It's an MPP compute cluster. That cluster uses Amazon's EC2 virtual instances. It can be provisioned and scaled in seconds to minutes. It can be sized for the exact requirements of each workload. So because each of these virtual warehouses, those sets of gears in this diagram, represent an independent compute cluster, if something is running, say a loading job is running on one of those compute clusters of virtual warehouses, and a different analytics job is running on a different virtual warehouse, the performance is not impacted by either of those running at the same time. So this opens up a lot of possibilities that make it a lot easier to bring together data. It allows me to have a central repository of data that can be seen by any virtual warehouse in Amazon S3. But it allows me to also then add additional workloads to be running analytics at the same time as I'm loading new data, and to do all of that without suffering from those concurrency issues that I would have seen in the past. Another thing that we do in the Snowflake architecture is we also make sure that we do this in the fastest, most performant way. And we do that by having intelligent caching that actually will cache locally next to where compute is happening, the data that's being used. So if I have, for example, an analytics job that's working on a set of data, that data will be cached in these virtual warehouses so that I won't have to load that data, I won't have to manage that data, I won't have to worry about things like partition keys. All that caching is happening automatically through the Snowflake software. So this is the way that we really were able to take advantage of the power of S3 and be able to do that in a way that didn't require the user to have to be the one who managed and set up all of the different capabilities that were needed to be leveraged within Amazon's S3. Another key part of bringing a lot of different data together is being able to handle different types of data in one system. So as Craig mentioned, in the Jana case, they actually had Avro data as one of the key types of data formats that they had in their environment. In a traditional environment, you would need to first transform that data, or you would need to put it into some other system before you could get it to a place where you could analyze it, particularly if you want to analyze it in conjunction with some structured data. In the Snowflake architecture, we actually designed a way that you could load both traditional structured data as well as semi-structured data such as Avro or JSON or XML natively without having to transform it first. It's then stored and optimized inside the Snowflake system so that when I want to actually access that data, I can use SQL to bring together structured and semi-structured data in a single query, but still have the benefit of full optimizations that a database knows how to do. So this is our approach to eliminating the trade-offs that you typically would have had in terms of the flexibility of the schema with the performance at runtime. We give you the flexibility of the schema and great performance at runtime because of this unique approach we've taken to how we actually store semi-structured data internally in our system. The last key thing about Snowflake is the fact that we put a lot of emphasis into designing a system that didn't require a lot of management and tuning. The more we see the data analytics use cases evolve, the more we see that that's often one of the big bottlenecks is that the analytics user or the data user needs to spend a lot of time either figuring out how to tweak and optimize the system themselves, or they need to spend a lot of time with IT to make that happen. And so we wanted to take as much of that as possible off of the data user so the data user could really focus on using the data. One part of that that's brought by the cloud is the ability to eliminate the need for your customers to worry about data infrastructure management. So certainly, the ability to have highly redundant, scalable storage is something that you don't have to manage at all as a user because it's provided by Amazon's S3 and the way that Snowflake uses that. Similarly with compute infrastructure. In the case of Snowflake, the user doesn't worry about provisioning any hardware. They don't worry about provisioning any virtual instances. They don't worry about installing software, patch management. All that's taken care of by the service. But it goes further in that it also goes to availability and disaster recovery. So in Snowflake, resiliency to a broad array of failures is just built in. It just happens automatically, and it's something that the user doesn't even need to think about. Backup is built in. It happens automatically, and it's available online for the users if they ever need to recover from that. The ability to have redundancy across multiple data centers is built into the service. Even the ability to have the upgrades of the software happen online, that's all built into the service. It's another aspect that a data user doesn't need to worry about. Similarly, a lot of the knobs and tuning that go into database management are also taken care of by the Snowflake service. So whether it's updating metadata and statistics, whether it's tuning, whether it's determining data partitioning and data distribution, whether it's other types of optimization, all of that is done dynamically by the Snowflake system. Because we just saw that the ability of a smart DBA to keep up with the growing number of users of data was quickly becoming a bottleneck for organizations using data. And then another key aspect of this is just the security management aspect. So as Mike mentioned, there's built-in security features in Amazon's S3 that we at Snowflake take advantage of without the user having to even think about it. So data is always encrypted in Snowflake. Whether it's leaving your system to go to Snowflake, that's encrypted over the wire, or whether it's data stored within Snowflake. All of that data is always encrypted, and you can't even turn that off. The key management for that is also handled by Snowflake, so you don't need to worry about managing keys. You don't need to worry about thinking through key rotation. That's all taken care of by the Snowflake service. And even things like intrusion detection and other hardening measures, those are all taken care of as part of the Snowflake service. So that was a really brief run-through of some of the key capabilities of what Snowflake provides. There's certainly a lot more information available on our website. We will also be inviting people who attended this webinar to be able to see the product live in an upcoming demo webinar as well. So with that, what I wanted to do was I wanted to turn it back to Craig, who's now going to talk a little bit about how Snowflake fit into their deployment and implementation. Craig?
Great. Thanks, John. So as I mentioned, we realized a while back that our growing volumes of data were going to reach a point where we could no longer operate the business efficiently. But we were really happy otherwise with the approach that we had taken and with the functionality that we had in our analytics system. So the problem we had was to figure out how to upgrade the parts of the system that were becoming bottlenecks to retain the other benefits and hopefully to reduce the amount of administration and overhead we had as we continue to grow. And so as you can see in the diagram that's up on the current slide, the high-level structure of our analytics system remains unchanged. However, most of the key components of the data pipeline have been upgraded. So we replaced HDFS as our long-term storage for all of the raw data with Amazon S3. And we've replaced MapReduce jobs that are running on our own hand-maintained and administered Hadoop cluster with the use of Amazon's Elastic MapReduce. In conjunction, these two changes have given us the ability to not have to worry about any administration at all for scaling or capacity planning or backups on our long-term data storage and our data processing. And then we replaced MySQL with Snowflake for all those benefits that John just mentioned. The rest of the system was able to slot cleanly into these changes and continue apace. But importantly, we weren't able to stop and just rewrite everything and then cut over all at once. We had to migrate incrementally as we went and as our business continued to grow. So the approach we took was to start by replacing MySQL with Snowflake. So we took the files that we had been loading into MySQL and simply copied them into S3 and then issued a copy command in Snowflake into tables that looked very much like the ones that we had been using in MySQL. This immediately enabled us to begin running queries and analyses that we had simply become unable to finish in MySQL as our data grew. We were able to backload months of data into Snowflake in less processing time than it took than it took to load simply the previous day's data into MySQL at the time we did the cutoff. We proceeded from there to rework our MapReduce jobs to run on EMR. Because we had to touch the code to work on EMR, we made the decision to rework a number of them to use Scalding, which is a Scala abstraction layer for MapReduce at the same time. Scalding is also a great tool if any of you are committed to writing Hadoop jobs. I recommend that you look at it. It made all of our code much more concise, and it was therefore easier to code review and debug, and it's easier to maintain. And we did that one by one, replacing pieces of the data pipeline into Snowflake, and then disabling the copying of the data that we had previously been loading into MySQL into Snowflake as we did that. We then we're beginning now to actually remove the MapReduce step from some of our data loads. We're able to do that because of the semi-structured access that John was just speaking about. So for one example, we have accounting records that come across in a nested Avro format, where one record contains updates to our balances with multiple partners. And to get that loaded into a SQL database, we need to flatten out that structure and to denormalize some of the data that's stored at the bundle level in the Avro data into each of the rows in the SQL tables that results. And with Snowflake's semi-structured data handling, we're able to replace a series of MapReduce steps with 3 or 4 SQL statements that were directly accessing the Avro data and loading them into the structured tables that our analysts were used to using. We're also able to issue some of the queries directly on the Avro data without having to destructure them, because the performance was much better than you would expect, again, due to the indexing and optimization that John mentioned within Snowflake. Our final step is going to be to simplify the moving of the data out of Kafka and into S3. Currently, we are briefly loading that data into our small Hadoop cluster and the HDFS storage there, and then uploading it into S3. But the last step that will allow us to finally spin down our now legacy Hadoop cluster will be to move data directly out of Kafka into S3. And that should happen within the next quarter. And then as reported, we also were able to simplify and rationalize our SQL schemas a little bit. We have been growing quite rapidly, both in terms of the amount of data we have, but also in terms of the number of employees who've been working on the system. And so there were some cases where we were able to remove some redundancy and simplify the schemas, which helps us ensure our data quality and also makes it easier for people to learn where the data lives inside the system. So we've achieved a number of benefits from doing this. All of our SQL database and all of our dashboards are now updating 6 times a day. That was the design goal. We actually could run it much more frequently, but our analysts like to know when the data is changing. They often run multi-step analyses and want to know that all of the tables are consistent, and so it's actually just helpful for them in the way they approach things. Snowflake gives us some capabilities that we may explore later to have the data continually updated for some people and not for others, but we haven't done that yet. The better performance that we see with Snowflake and the simplified table structures that we're able to put into place as we migrated have increased the usage within the organization. We have more than 60 employees who log in and issue queries to Snowflake, up from about 30 before we made the change. This is in a company that's approximately 75 people right now. That was actually astounding to me when I pulled the number. And I think that's a testament to how easy and performant it is to access Snowflake, particularly using their web interface. And that's lowered the barrier to entry and enabled us to get people who have never issued SQL queries in the past at any previous job into the system and productive very quickly. The biggest benefit, probably at least from the engineering side, has been significantly reduced administration overhead. Each of S3, Elastic MapReduce, and Snowflake are trivially elastic, and capacity planning is simply something we don't have to worry about for any of those anymore. We can throw more compute resources at our Snowflake system with a couple clicks on an interface. We can throw more compute instances at an Elastic MapReduce job by changing a number inside our launch script. And so there's a large amount of time that's simply been freed up. Similarly, we don't need to spend a whole lot of time tuning our table designs or database parameters anymore. In fact, the biggest problem I've had with some of the engineers is that they would like more knobs to turn, even if things are already optimal. But they've come to accept that clear logical design and well-written SQL queries is all we need to do with Snowflake to get the kind of performance that we need. And in the rare case where that hasn't happened, Snowflake support has been able to fix the issue quite rapidly, on the order of hours or minutes rather than days. And finally, we haven't needed to worry about backups or disaster recovery. And in aggregate, this has freed up about 25% of our ops team's time when compared to our last quarter with the previous system. Finally, as we did the migration, we invested in performing significantly improved testing of the data pipeline. And Snowflake was quite helpful here too, because it's trivial for us to spin up separate warehouses to run our testing against, which allows us to run testing workloads without impacting the production workloads. Complete isolation there, while being able to use snapshots of existing data if we like. The net effect of all of this is that we're able to focus on our products and better understanding our business and less time simply trying to operate our analytics system.
Thank you, Craig, and thank you to all our presenters today. If anyone had trouble understanding Mike Ruiz due to audio quality issues, you can feel free to reach out directly to him, and we will have all of our presenters' information on your screen at the end of today's presentation. This leads us now to our question and answer portion of the presentation, at which time I'd like to remind you to please submit your questions in the chat window of your lower window of the ReadyTalk platform. In the meantime, while our speakers are going through the questions that have been submitted, please answer our quick poll question. How much of your data is in the cloud? And John, any comments on what the poll is indicating here?
One thing that's kind of interesting is that when I've asked this question to different people, I often find that even within an organization, people don't necessarily have a good handle on how much data is in the cloud. So someone might think that they have no data in the cloud, and you ask somewhere else, someone will say that they have several terabytes in the cloud. And so I think this is a little bit consistent with that in that a number of people have a small amount of data in the cloud, but then I am seeing more and more, as people start to look across the organization, they are finding lots of different places where data is being stored in the cloud. So it's kind of interesting to just see how that's happening organically.
Great, thanks. All right, well, let's dive into the questions and answers. And John, we actually have our first question for you. And what does Snowflake cost?
Yeah, so one of the things that we did with Snowflake was we changed the way that you approach the cost of a data warehouse in a couple of key ways. In a traditional appliance-based data warehouse, of course, you pay for the entire hardware, and that includes both compute and storage, as well as things like network. In the cloud, you obviously have the flexibility to pay for only what you use. So one key part of the model that Snowflake has is that, like with most Amazon services, you only pay for what you actually use. And in terms of what that means in Snowflake, there's actually two components. We've separated out the storage from the compute, and so that makes it possible for you to take advantage of the pricing of those separately. So rather than having to pay for a very large virtual instance in Amazon and including the storage there to store all the data that you have, with Snowflake you can actually pay for the cost of the amount of data you're storing separately from the number of compute hours that you're running. So it gives you the flexibility that if you have, for example, a huge amount of data but you aren't using it at a certain time, you're not paying for the cost of compute for that data. You're just paying the cost of cloud storage for that data. And then if you are using that, you're paying for the compute hours and the compute horsepower used by those virtual warehouses. So it gives you a lot of flexibility for cases where you may have a spike. You may have a workload that needs a lot of resources at a certain time of year or a certain time of week or a certain time of day. And you can allocate those resources to it on the fly. But you don't have to keep those resources running. You don't have to pay for them if you're not using them anymore. So it gives you a lot of flexibility there in terms of the cost.
Great. All right. Well, our next question is for Craig. Can you share with us how you manage permissions within Snowflake? On a similar note, what's your SQL deployment process like?
Sure. I am happy to do that. Snowflake has object-based permissions where the rights to manipulate each object within the database is assigned to roles. So we're currently using a very simple permission scheme where there is one role that is only used by the user that performs our automated updates to all of the data within the tables. And that is the only role that role owns all of the tables and the database that has the data that's being updated, and it is the only role with update or delete permissions to those tables. We have a separate role to which all of our human users are assigned that has only select permissions to all of those tables that have the primary data. They do have the ability to make their own tables in separate schemas if they need to perform multi-step analyses or they want to take a snapshot of the data for some reason. But that's our approach to managing the access. There's certainly more complicated schemes that are available, but that's served our needs so far. The second question is to our SQL deployment process. For all of our code we actually do, this is both our analytics code and our production web systems. We do continuous deployment. So every single change that is made by an engineer is deployed to production shortly after it is merged. And as part of that, there's an automated testing step. So we use Jenkins to watch when the GitHub repos that house all this data are updated. It will then run a series of automated tests, regression tests, against the, from that repository to sanity check the changes and ensure that nothing is likely to break. And then it is simply deployed out into the production systems by the Jenkins system.
Great, thank you. All right, another question coming in through the chat. Why the company name Snowflake? Any relation with the type of solution it offers?
Yeah, it is actually a question that we get quite a bit, not surprisingly. So it turns out that there's a story behind the name Snowflake. And the story basically is that the founders and one of the first funders of the company all had a love of skiing and the mountains and things. And it actually was something where one of the first funders, his daughter was actually in a ski class taught by one of our company founders' sons. And so as a result, there were just a lot of connections to snow and skiing. And when you think about it, it actually also can apply to the company as well. Snowflakes come from the cloud, so there's a kind of a natural tie there. And of course, there is a term, a Snowflake schema design that is often used, or Snowflake data model that's often used in data warehousing. So even though we actually support both star and Snowflake models and schemas for data, there is that connotation that it is connected to data warehousing. So it really just fit the company in a way that we really thought was great.
Thank you, John. Another question for you. Which database is Snowflake based on?
Yeah, so Snowflake actually has a team that has built a number of different database and data warehousing engines at other companies in the past, and so it has the experience that allowed us to actually go and build a completely new database engine. So we didn't start with an open source database. We didn't start with an open source NoSQL database. We actually built the core database engine ourselves because we really saw that there were a lot of benefits if we could do that, and so that's why we did that, to take advantage of the cloud.
Great, thanks. And what tools can be used with Snowflake?
One of the great things about being a SQL database is that there's a whole universe of tools and ecosystems that have been built around SQL databases. And so because we do support standard SQL, we're able to support pretty much all those tools that know how to speak to a SQL database. ODBC and JDBC are the most common interfaces that people are using. So that's a great way for people to connect to a large variety of tools. And then in cases where it makes sense, we've also developed direct integrations. So for example, we have a direct integration with R that allows you to more easily move data sets from an R environment or from Snowflake to an R environment for analysis. And we've also been working with some of the key ETL and BI vendors so that in cases where there are benefits that those tools can take advantage of inside of Snowflake, they're able to natively take advantage of those directly as well.
Thanks, John. Question for Jana. What BI analytics tools are being used? Are they using Snowflake data directly?
Yeah. The primary tool that we use is actually simply Python notebooks. So, and a little bit of R. We have a team of data scientists that build their analyses using these tools, and they are directly accessing Snowflake. Beyond that, we're not using any standard BI or analytics tools because, as I mentioned earlier, we have a very technical team and people actually want to just directly get into SQL queries and issuing those.
Great. Thank you. Another question for John. Is Snowflake available in Amazon Marketplace as an AMI?
Yeah, so Snowflake is actually not an AMI. An AMI, for those of you who are less familiar with Amazon, is basically a prepackaged virtual instance that includes your software configuration. Because Snowflake is delivered as a SaaS, software as a service application, it is not available as an AMI. And historically, AMIs had been the types of applications that were available in the Amazon Marketplace.
Thanks, John. Well, we are approaching the top of the hour, and that is all the time we have left for today. Again, if your question was not addressed directly, we will be following up with you individually by week's end. Again, each presenter's contact details are available on your screen, and Snowflake will be following up with you with a link to today's recording. Thank you again to our presenters from AWS, Jana, and Snowflake Computing. Thank you for joining us. Have a great day.